Hey guys, today we're going to be wrapping up chapter 3 by looking at something called outliers. This is a term that you probably heard at some point in your life. Maybe it'd just be in regards to, oh, that person's an outlier because they're different, or this particular statistic is an outlier because it's different. So this little illustration here of this red fish is the outlier, and this school of fish obviously it's swimming the wrong direction and is the wrong color. So we're going to be identifying outliers. If you think back to box and whisker plots and the 5-number summary, we're going to use that to identify outliers in a data set. So first of all, just the definition of an outlier. Basically, to identify an outlier, it's a number that falls outside of this following range that we're going to identify here. So you'll find this maybe looks a little bit similar to when we did the Chebyshev theorem, except there's only really one formula. We're going to compute a range using some statistics from our 5-number summary. And if number falls outside of that range, we're going to classify it as an outlier. There is actually a number of different ways that you could identify outliers. This is one way that you can. It's a pretty commonly used way to identify outliers. So with that, let's go ahead and give you that formula. So we're going to have a lower limit and an upper limit. And if a number falls outside of this range of the limits, then we say that it is an outlier. So the lower limit is going to be Q1, which if you remember, that's quartile 1 from box and whisker plots, minus 1.5 times the IQR. That is the interquartile range. So Q1 stands for quartile 1. Remember, that's the median of the lower half. And then IQR is the interquartile range. That is, and if you forget what IQR is, interquartile range, that's Q3 minus Q1. That's how we compute that. So it's going to be Q1, whatever that value is, minus 1.5 times the interquartile range. If you think back to box and whisker plots again, we had, it looks something like this, right? It's here. So Q1 occurs right here. That's the median of the lower half. Q3 is up here, the median of the upper half. So interquartile range is this area in between here. So we do Q1 minus the IQR times 1.5. And then to find the upper limit, we're going to do Q3 plus 1.5 times the IQR. So Q3 obviously stands for quartile 3. So quartile 3 plus 1.5 times the IQR. So similar to the Chebyshev theorem in that we're doing sort of like a value minus a multiple of some number and a value plus a multiple of some number. So these formulas, you don't necessarily have to memorize them because like everything in this current format, you can always look at your stuff. But definitely write this down, have this handy when you're doing the assignment. All right, so with that, I wanted to first review one thing, and that is the 5-number summary. To compute this on your calculator, because you're not going to want to do all of these by hand. You are going to want to use your TI-83 or TI-84 calculator to do so. So I thought we'd first start by doing a review of that 5-number summary, just how you calculate that. So the first thing you do for the 5-number summary is click on Stat. And then you're going to see this screen. And then you're going to want to click on Edit. From there, you're going to see these lists come up. Hopefully yours says L1. If not, there is a way you can change it to that L1, but it's okay. Like if it says L3, that's fine. Just go ahead and type it into whatever it says for the L1 or L3. Hopefully it says L1, but you're going to type in your data. So there's an example of some data that I typed in. All right, and then after you type in that data, you're going to hit Stat again. And then you're going to move over to Calc. So you're going to tab over to Calc, and you're going to click on one var stats. So that's where you want to enter on that, one var stats. You'll then see this screen. The important thing here is the list the list must match whatever you typed your list into. If you typed into L3, then it must say L3. If it doesn't, what you do is you click, you hit the second, and then you see this list here. So if it doesn't say L1, you need to change. If it says L1, you need to change it. You just, on that list one, you highlight it, and then click second list, and then select whatever list you typed it into. Then after you've done that, you go down and hit enter on calculate. Then you'll see this screen. So thus far in the one of our stats, we mostly just use this part of the screen. We generally use this X bar and the S of X, that's standard deviation, or sigma. However, notice there is a little arrow down. So you actually want to hit the arrow down there, arrow down, and you'll see what we're looking for, which is this. This is your 5-number summary. It gives you the min. So if you're to do box and whisker plot, it'll give you the minimum. Quartile 1 is right there. It gives you the median, 9. Quartile 3 gives you as well. And then the max. The two numbers that we need for this to find the outliers is Q1 and Q3. So I would write those out. And then we can apply the formula that I just outlined on the prior slides. All right. So in our first example, the number of matches won by 12 teams in the National League are 11, 5, 6, 6, 9, 10, 9, 14, 11, 9, 9, and 6. You do not want to write these out, find the median, then find the quartiles. Much easier to do it on your calculator. So for this one, I've already typed it in. It's actually the one that I just showed you. You're doing stat, edit, type it into list 1. You're then going to do stat over to calc, one of our stats. Calculate, scroll down, and the two things we need, whoopsies, are Q1, which is 6, and Q3, which is 11. All right, now I'm going to use my formula to get my lower and my upper bound. So my first one, for my lower, it is Q1, so that's 6, minus 1.5, that'll always be 1.5, times the interquartile range, which means I need to calculate my interquartile range. So that's an easy calculation, IQR. It's just Q3 minus Q1. So we got that. 11 minus 6, which is 5. So again, this is Q1 minus 1.5 times the IQR. So in this case, it's 6 minus 1.5 times 5. So my lower is going to be 6 minus, and I would actually just put it in parentheses, type it all in 1, and you'll get negative 1.5. My upper bound then is, it's not quartile 1. Be careful, it's not the same number. It's Q3 plus. So two things change. Changes from Q1 to Q3 and changes from a minus to a plus. Plus 1.5 times the IQR. So Q3 was 11 plus 1.5 times 5. Type that all in. 11 plus 1.5 times 5 gives me 18.5. So my range then is negative 1.5 to 18.5. And actually, I'm going to use brackets. Brackets mean it just includes that value. So if anything falls outside of this, so if a number is bigger than 18.5 or smaller than negative 1.5. So smaller outlier equals smaller than negative 1.5. Well, that's definitely not going to be possible because we're talking about wins. You cannot have a negative number of wins. Or larger than 18.5. If it lands exactly on that, you would not consider an outlier. It's only if it's larger than or smaller than. So this one we want to look at here, it asks if it's true or false that 18 is an outlier. 18 is larger than 19, or sorry, 19 is larger than 18.5. So it'd be yes, 19 is an outlier. So you could say maybe that team is exceptionally good. They are far and away better than all of the other teams because it was an outlier compared to their wins. So definitely a superior team. All right, let's go ahead and look at the next question. So this one, we're just going to look at a box and whisker plot and make a determination. We're not going to use the 5-number summary, but we need to be able to identify where these things occur on this box plot. So the question is 92 an outlier? 92 is out here. It's pretty far out there, but is it considered an outlier? It's a good question. All right, so in order to calculate this, we still need our same things. We need our Q1. Q1 occurs right here, and Q3 appears right there. So if we look down, Q1 is at 48, and Q3 is at 64. And then let's go ahead, we know we're gonna need our IQR, so let's go ahead and calculate that. IQR is 64 minus 48, which is 16. So those are my 3 things I need. From there, I can do my lower. Now, technically on this one, you don't really need to do a lower because we're just asking about 92, right? And obviously 92 is not gonna be below the lower bound, but for the sake of doing it, let's just go ahead and sake of practice here. So remember for that one, we do our Q1, which is 48 minus 1.5 times IQR of 16. Can type that in. It's gonna be 48 minus 16, and we get 24. So if a number had been below 24, it would be an outlier. Our upper then is Q3, which is 64 plus 1.5 times the IQR of 16. And that puts us at 88. So our range then would be 24 to 88. If the number falls outside of that range, it would be an outlier. So 92 does, it's greater. So this would be yes, 92 is an outlier. You might have, if you follow any of the election stuff still, whether there's fraud in the election, right, is a big story. Obviously Trump is claiming there's lots of fraud. And one way that they're trying to prove that there was fraud in the election is to look at specific counties and specific states and say that the number of votes in this particular city or this particular county is an outlier, because if you look at all the other votes in all the other cities and counties, they sort of follow this pattern. But if you look at this one specific county or this one specific city or this one particular tally of votes, it is an outlier because it's so much higher for one particular candidate than you would expect. So statistics are actually being talked about a lot right now in terms of the election and determining whether there is fraud in the election. And the primary way that they're actually doing that, besides personal testimony, is to say this isn't right because it doesn't fit in our statistical model of what we would expect. So from years past, what we would expect a particular place in the country, the results to be, or just in comparison to all the other cities or all the other counties, this one sticks out. It's an outlier, so therefore we should look at it, we should recount it because it doesn't look like it's right. So these outliers are actually really important in a lot of areas of life, not just election, but it could be like if you're manufacturing a product and you accept some certain level of error within the product, and if it fits outside of that error range, it's an outlier, then we need to discard it or something like that. So it is a very important concept that you understand this. Again, outliers could be calculated in a slightly different way, but this general concept holds true. Another thing, just as we're looking at this particular slide, you can identify outliers some just visually. So like, for example, this 92, if we were to look at interquartile range, it's this box here, right? And what we're saying is if a number falls outside of 1.5 times that, then it's an outlier. So if I were to take this box and sort of replicate it, it won't be exact. So 1 times that box would maybe be about this big, just eyeballing it. Then another half of one of these boxes, so maybe right here, about half of the box, maybe about right there. If the number falls outside of that, that means it's an outlier. And you can pretty clearly see, I think, on this one, if you were to take that box and replicate it once and then another half of it, that 92 would be outside of that. In the same way that if we were to draw it this way, if I were to draw this box, it'd be a little bit too long there, another half of it. So a number outside of 1.5 of those boxes, either direction would be an outlier. So numbers out here would be outliers, and numbers out here would be outliers. So that's what we're saying. If we take that box, the interquartile range, add it to either side, and then another half of it to either side, if a number falls outside of that, then it is considered an outlier. So hopefully visually that makes a little sense as well. All right, last one here. We are going to identify all of the outliers in this data set. So the first thing we need to do is type it in. So go ahead and take a minute and do that. Type it all in and compute the 5-number summary for that. And I'm going to finish typing it in here real quick. Just bear with me here. Hopefully I don't miss one. Don't make a mistake. All right. Looks good. Good idea to always double check your answers. Check your data. Also double check how many you typed in as well. So it looks like we should have, I typed in 15 values, so I'm just going to count them. 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15. All right, so it looks like I got them all. So my interquartile range, Q1 and Q3. Q1 is 70, so hopefully you got that. Q3 is 95. And the IQR then is 95 minus 70, which is 25. All right, so those are our 3 data things that we need. We need to calculate our lower and our upper. So our lower is going to be Q1, which is 70 minus 1.5 times the IQR of 25. And our upper is going to be our Q3, which is 95 plus 1.5 times our IQR of 25. Go ahead and do those calculations real quick. For the lower, we're going to get 32.5. And for the upper, we're going to get 132.5. All right. So our range then would be 32.5 to 132.5. So we're looking for numbers that either are below 32.5, numbers that are above 132.5. So I'm going to go through and just circle them. Below would be here, 31. And then above, it looks like we've got 174. I think that's it. I didn't miss any. That looks good. Yep. So we've got 2 outliers. We've got one that's below and one that's above. So 31 and 174 are outliers. Sometimes what we want to do is like what we did with our trimmed mean. If you want to identify the outliers and then exclude those from your data set so they don't affect your data too much overall. So, all right, that is about all there is for outliers. Reach out to me if you do need some extra help on this, and best of luck, guys.